So here we are looking at several examples. We're going to do one together. I'm going to have you try one, and then we're going to look at some other examples that you might see in your homework, or you will, different types that you'll see in your homework. I really stepped it up a notch on this next example, number 42. So I want you to pause a minute and ask yourself, what's different? What's different about this one than the one we just did at the top of the page? One thing you might notice is there's more going on than just a radical. There's a radical minus 3. That minus 3 is outside, so we're not starting with the radical by itself like we did in example number 10 above. Also, there's an x on both sides. And remember, when we talked through the steps just in the previous video, it didn't matter if there were other x's. Our goal is still the same, to get the radical alone. So we're going to start by adding 3 to both sides, so that we get radical x is equal to x minus 6. Our goal here is to get the radical alone. Okay. Once we've done that, even though there's an x on the other side, we can go ahead and square both sides. That's our second step, and I'm referring to the steps up at the top of your notes on this page. It's out of sight of the camera, but you can see it up on the page. I'm pointing to it here with the pen. So now we're going to square both sides. Now remember, two things here. The squaring of the radical simply undoes the radical operation. It does nothing to the inside of it, the radicand. Okay, the square here undoes the square root, and then that's it. It's done its job, leaving behind just plain old x. The other thing I want you to note is that when you have something squared, it literally means x minus 6 times x minus 6. You have to go ahead and FOIL that. Don't get sucked into, oh, that's just x squared minus 36 or plus 36. There is that. X times x is x squared, minus 6 times minus 6 is plus 36, but there's also your outside outside, which is a minus 6x, and your inside inside, which is a minus 6x. So don't forget the OI piece. Very important. What that looks like then on the right side is x equals x squared, combining like terms, minus 12x plus 36. Okay? And at this point, that's all the new material right here. This is the new stuff, where we're getting the radical alone, squaring it, and then from then on out, this is old stuff. This is solving equations based on what we see. Now this is not as old as the one we did earlier, because we're going to have to use factoring and the zero product property, which I'm going to abbreviate ZPP. I'm sorry, zero product principle. I was taught it property. It's being presented in this book as principle. Same idea. Use factoring the zero product principle to solve. And that's your chapter 7 stuff. Okay. So let's look at that. We're going to start by subtracting x from both sides, because we want to set it equal to 0. When you have a quadratic, in other words, x squared involved, you can't just get x alone. So our technique at this point, what we have in terms of a strategy, is we get it to standard form, which means it's set equal to 0. So we do that by moving the x over. And then we're looking to see if this will factor. And indeed it does. This factors into x minus 4 and x minus 9. And then you use the zero product property and say, okay, well, if I've got something times something equals 0, either that first something, x minus 4 equals 0, or that second something, x minus 9 equals 0. And you solve those and you get x equals positive 4, x equals 9. But we need to make sure we always check. So we're going to take those and we're going to check in the original equation. So I'm going to take my radical x minus 3 equal to x minus 9. Notice I leave spots for the x here, and I'm going to put in 4. And does that equal when you put in 4 over here? So square root of 4 is 2. 2 minus 3 is negative 1. Over here, 4 minus 9 is negative 5. These are not equal. That means x equals 4 is an extraneous solution. It does not work back in the original problem. Okay? Because it creates unequal sides. When you take the square root of something and then square it, you've added in the potential for a possible algebraic solution that does not work back in the original. And then let's try checking the other solution, 9. So again, I'm going to take radical x minus 3 equals x minus 9, leave myself some workspace. I'm going to try 9 in there. 9, does that equal? Put 9 in for the x's. Square root of 9 is 3. 3 minus 3 is 0. 9 minus 9 is 0. These are equal, so this is our solution. X equals 9 is our final solution. And I'd like you to try number 8. But before you start, ask yourself what's different about this one. That'll go a long ways. If you can verbalize what's different, then you can get it to where it matches what you know how to do, and then you'll find that the steps fall in place. So I'll give you a minute to kind of look at that, ask yourself what's different. This would be a good time to pause the video, make sure you have copied the notes, you understand and can follow what happened before, maybe talk it through out loud to yourself or someone else. That's a great technique to start getting ready for exams, and it's never too early to start getting ready for exams, right? They're always just around the corner. But talk this through, what's different, and then try it, pause the video, and when you unpause it, we'll reveal the answer. Okay, so one of the things you might notice that was different is you've got a radical, not quite by itself because we have the minus 8, similar to what we had in this one, which means that you're going to need to move that 8 over, get the radical by itself, and then square it, and then solve from there. When you do, you should get an answer of x is equal to 59. And if any of these try questions in the notes stump you, bring those to class. I'm happy to do those together. I just want to give you a chance during the process of the notes while you're watching examples to try them to see if you're ready for the homework. Homework will go much smoother if you've given it a little bit of a try before you just jump in after watching all the notes. Okay, so let's try number 24. It has a big what if in front of it. In other words, what if it looks like this, meaning there's something different about this one? Well, we've got 3 times a radical. X minus 2 happens to be under that radical. We also have equal to another radical, 7x plus 4. Our goal hasn't changed. Our goal is still to get the radical alone. But as we look at this, we realize, wait, if I divide by 3, to get this radical on the left alone, then the one over here isn't alone. It's going to be divided by 3 or multiplied by 1/3, however you want to think of that. And this is the reason why I picked this one, because I wanted to show you what you can do here. Because it's not adding or subtracting, this number being multiplied out front, this 3, is okay to stay there. We've gotten this as alone as we can get. Go ahead and square both sides. So we're going to go ahead and take the 3 radical x minus 2 on the left and square it. Take the right, because what you do to one side, you do the other. So we're going to go ahead and square the right side again as well. And when that happens, remember that you are distributing that exponent. Whenever you have the rule for having an exponent, product raised to an exponent, something multiplied. The 3 is multiplying by the radical here and it's raised. The square applies to both the 3 and the radical. Well, when it applies to the 3, you get 3 squared. When it applies to the radical, it undoes the radical. Remember, that was the point, and that's its job, and it just leaves behind the x minus 2. Still multiplication, because that was what was in between them first of all, is multiplication. On the right side, when you square it, again, the square is doing its job of undoing the radical operation, undoing the square root, and that's all it does. It does not touch the inside. It just removes that operation of a square root. From here, 3 squared is 9. So you get 9 times x minus 2 equals 7x plus 4. We will go ahead and solve. So at this point, here's, this was the new stuff. But from this point on, it's old. It's how to solve equations. This should be familiar to you. And again, if Math 60, you're struggling with any of that, or still struggling maybe with Chapter 7, factoring and zero product principle to solve, please make sure you come and get some extra help in class. That's what class is for. Tutor, Student Learning Center, buddy or family member that is confident in their mathematics, whatever it takes, get the help. Don't sit there with questions. We want to help you. We can't tell if you need help unless you ask. So please ask. Okay, so we distribute 9x. 9 times minus 2 is a minus 18. Equals 7x plus 4. We're getting x to one side by subtracting 7x from both sides. I'm going to go ahead and conserve space and time here, and since I'm moving x to the left, I'll go ahead and in one swoop move the numbers to the right. That will leave behind 2x on the left side equal to 22 on the right. We're going to divide both sides by 2, and that gives us x equals 11. And we're going to check, because it's very important to check back in the original. My original was 3 radical x minus 2 equals radical 7x. Oops, 7x plus 4. And I just want to leave a workspace so I can plug in my answers. So I'm going to try 11 everywhere that I saw an x. And I'm just checking to see if that works. So 11 minus 2 inside the radical is 9. Square root of 9 is 3. 3 times 3 is 9. So that's what I get on the left. 7 times 11 is 77. Plus 4 is 81. Square root of 81 is 9, so it does work, it checks. So our answer is x equals 11. Let's look at number 26. Always good to kind of pause and look at it before you dive right in. Here's the radical. It's got a plus 4. My goal here is to get the radical by itself. So we start by subtracting 4 from both sides, because our goal here is to get the radical all by itself. 2x minus 8 radical equals negative 4. And then I'm going to square both sides. So I'm going to go ahead and rewrite that. 2x minus 8. Let's give us a little bit clearer space here. Square both sides. Why? Because we've got the radical by itself. We want to undo that radical operation. We want to undo the square root. So we do its opposite, and that is to square it. And what that does is it gets rid of the radical. The square does its job by getting rid of the radical, and that's all it does, leaving behind what was inside, 2x minus 8. Over here, negative 4 squared is literally negative 4 times negative 4. That's going to be a positive 16. Then we solve. This is all now familiar territory. We've done the new piece of chapter 9 here. Now we're going to apply what we know from earlier. Plus 8 on both sides, you get 2x is equal to 24 divided by 2 on both sides. You get x is equal to 12. We want to check that back in the original. And I'm going to move that over here to check it. Our original was radical 2x whoops, sorry. Oh, we'll try that again. My apologies. Radical 2x minus 8 plus 4, does that equal 0? And let's take our answer of 12 and try it. So we'll put 12 everywhere we saw x, and we're just checking, so I use the question mark as a reminder. 2 times 12 is 24, minus 8 is 2 times, wait, did I copy that right? Yes, minus 8. So 2 times 12 is 24, minus 8 is 16. Radical 16 plus 4, does that equal 0? Radical 16 is 4, 4 plus 4 is 8. 8 does not equal 0. And since that's the only solution here, not only is it extraneous, it means there's no solution whatsoever, because the one answer we got algebraically does not work in the original. Let's take a moment to analyze what just happened here. Why, when this one looks so much similar to the one you may have tried up above, why did this one not work out? Well, right here, if you'll notice, right at the beginning, we ended up with a radical equal to a negative number, equal to a negative 4. And a square root, a principal square root, if there's not a negative in front of it, then we are creating a positive answer. We're looking for the positive square root. So right here, a positive square root equal to a negative number, not possible. Okay? We were able to continue with the algebra. There was nothing wrong with our algebra, but we were trying to create a situation that just doesn't work, because you're going to get a positive answer here when you take the square root, and then when you add 4, you're still going to be positive. There's no way you can make that equal to 0. Okay? So sometimes some of these problems will be kind of a giveaway whenever you have a radical equal to a negative number. Now we're just talking about square roots here, okay, even roots. That's not possible, and so you can jump right to no solution. But if you forget about that little time saver, you can always just follow the steps just like we've done. As long as you check your solutions back in the original, you'll come up with that same answer, that it was extraneous and so there's no solution. Okay, moving on to page 2.